I'm not teaching, I'm publicly learning. But hi and welcome to Learning for Life in UK test, part 408. Scientists, engineers and inventors, that is on page 170, while doing standing electrogymnastics. And if you participate in the standing electrogymnastics, that is it. So the first exercise is, I think it is the moderator. Where your feet singing together. And we're going slowly with weight in front, slowly back. So the first scientist here named is Sir Edmund Halley. That was there with the Royal Scientists Academy there, I think. Edmund Halley, he prophetized there that the comet comes back. And it did. Now it's called the Halley comet. But it was the Royal Scientists. I think it was under Charles first. It must have been earlier, but who was it? It is on page 30. Who was it? Charles II. Charles II. So after the Restoration was it? Where the Royal Society was formed to promote natural knowledge. And one of the scientists was Edmund Halley, who successfully predicted the return of a comet now called Halley's Comet. So the Royal Society, and it was Charles II. During his reign, also we have various coppers. And the next exercise, we're having one leg in front, we're going in front, and again back. We're lifting the toes in front, and the heel back. Now Sir Isaac Newton, he went to Cambridge. He studied natural philosophy, and he wrote a book, Philosophia di Mathematica Natura, Mathematical Philosophies of Natural Mathematics, Philosophies of Mathematical Scientific Reality. He wrote a book, and he also discovered that light has many different colors, and his ideas to science, I think they named them gravitation, are still important. Mathematical Philosophies of Natural Philosophy. And now the next person is James Watt. James Watt. It was not your Watson Watt. So who was James Watt? It is directly I recall before Richard Arkwright. Yes, we had it in the last chapter, we read it. It was James Watt who, when he just said one sentence, he worked on the steam engine. That is all what was written there. That is on the page 35. He improved the steam engine. James Watt's work on scientific discoveries, such as James Watt's work on steam power, helped the progress of the Industrial Revolution. That is all. When Richard Arkwright, he made a carding machine. And we're going to the next exercise. Yes, we had both feet up, I think. Next exercise, both feet split out, and we're going from one side to the other, and we're lifting the heel off the ground. So, Richard Arkwright, he made a carding machine. That has something to do with making the yarn coming out into multiple different yarns to make them textiles of them, and that thing is way faster if it would be done by hand. Furthermore, was he a successful company leader, and his company worked great under his leadership. Now there was George Stephenson, Robert Stephenson, all the Renaults, we had it in the last part more or less excellently, that they pioneered in the railway. They made something with trains, I guess. There was not much more. Then there was Eichenbach the Kingdom Brunel. He was an architect and he made bridges and tunnels and so on. Some of his bridges are still standing. The next exercise. Yes, here we go, more like that. Having one foot in front. And we're bringing the weight onto the leg in front. And we're going back. Yes, I think that was also Eichenbach King Brunner. We're going to go through the whole book also again, but I think that was not much more. And if we totally forget that one fact, then when we read it again, we will directly see that was the missing thing. We will know what we're missing. Otherwise, we don't know what are the missing things, basically. So there was when Ernst Rutherford was mentioned. Ernest Rutherford, he was a chemist, but what had that to do with this book? Page 51. Okay, we're going there, 51. We're changing the name. Also to the atom bomb. The war against Japan ended in August 1945, when the United States dropped its newly developed atom bombs on the Japanese cities of Hiroshima and Nagasaki. Scientists led by New Zealand-born Ernst Rutherford, working at Manchester and then Cambridge University, were the first to split the atom. So that is it. So Ernst Rutherford, he was New Zealand-born, and he was the leader of in Manchester and Cambridge University working team who first split the atom. Okay, I'm thinking about something. Okay, we are doing the next exercise, that is we're feet standing together and we're leaning in front onto the toes. First we're going on. So there was when Alexander Fleming, and he discovered penicillin when working on the flu. I don't know if there was more. But let's look actually for that. That was on page 52, so after the Ernst Rutherford mentioning. He was researching influenza, the flu, in 1928 when he discovered penicillin. This was then further developed into a usable drug by scientists Howard Florey and Ernst Chain, when they are named here. Are they named here? No, they are not named here. And so Howard Florey and Ernst Chain worked further on that. By 1940s, it was in mass production. Fleming won the Nobel Prize in Medicine in 1945. Penicillin is still used to treat bacterial infections today. HATMHZXA, no. But no to have you left? Yes, we have in calf phrases. So we're coming up onto calf phrases. Up onto toes and again down. And when there was John Logie Baird. Now we're on the big scientists page. So John Logie Baird, he developed the television. In the 1920s he developed it. And in 1934, 14 years after the radio, I remember something about 14 years after the radio. Radio was in 1922 by the BBC. So 1936. It would be after the radar. So it was 1932. It was 10 year after. No, I have it all confused. He developed the television and broadcasted from London to Manchester. What was it? John Logie Baird, 56. It was 1932, so 10 years after the BBC made the radio broadcasting. And it took 12 years from radio broadcasting, which the BBC did, to the regular broadcasting. No, 14 years. These were the 14 years. These are the 14 years. So 10 years after radio, and it did take the BBC 14 years. That was the last exercise. Now we're having one leg with a calf on the ground, and we're stretching a bit, with heel on the ground. We're stretching a bit in front. Now when there was Sir Robert Watson, and he made the radar station, and it was first successfully tested in 1935. He had the idea of changing the leg, that radio signals could be used to detect planes. And when there was Sir Bernard Lovell, he built the Jodrell Bank in Cheshire, the largest radio telescope, and it is still in use. And it was still in use, and I think there was one more. So this was the standing leg gymnastics, which has a disadvantage that might cause motion sickness. But otherwise, if you were just here for that and you want to go on, in the next part we're going to talk more about further scientists, engineers and inventors, and you can go directly to the next part. Otherwise, I don't know if it's completely related to that, but I think when we had the split the atom, which was done at Cambridge and Manchester by a team led by Ernest Rutherford to make the atom bomb, I think I mentioned something like, I don't really understand that, and I don't understand it yet. But in the meantime, I heard something about making atom bombs, or more precise, to enrich uranium. Now, the idea is what was explained was that the uranium used is a specific type of isotope, so with a specific number of whatever protons or so. There are different types of uranium. Of many different things, there are different types. And they have been called isotopes because they have so many of that element, that protons or whatever in them. So there is uranium, I think 235, so it has been 235 electrons or what is used, and there's another type of uranium, let's say uranium 125. And now if these two uranium just exist, that is okay, they are radioactive a bit and so on, but you can't make an atom bomb out of them. You need to enrich uranium to make an atom bomb. And to enrich them, it was explained that they are very fast in a centrifuge turned around, and the one type of uranium, 235, has more electrons, so it's a little bit heavier. One of the two uranium types, uraniums, is heavier, and the thing which is heavier is pressed more to the side. That's just physics. So a thing which is heavier was, I don't really get it, but it's very fast centrifuged or spin, and now the heavier one of the uraniums comes to the side, and the uranium which is 235, I think was it, stays more in the middle. And now we can take the uranium in the middle, and that is then enriched uranium, a little bit more enriched. And if you do that then again and again and again, you do it thousands of times, this spinning, and take always the thing of the middle, you get more and more enriched uranium. First you get 1% uranium 235, 2, 3, 4, 5. If you've done it a couple of thousand times, you have uranium 235 with 9% or 100% or whatever is needed. And if you have that uranium, then that can be used for an atom bomb, because by the atom bomb, then all this energy which is then in the uranium 235, I don't really understand how it works, is then released in 1 second, and that gives the supermassive bomb of the atom bomb. And there was one explained, if it's used for reactors, so for electricity generation, then this uranium is only very slowly released, and then it is not needed to enrich uranium to over 20%. If you want to get the electricity, you then have the atom bomb basically, and you let very slowly this energy coming out. You catch it, and then you have electricity. Also, if you want to build an atom bomb, you have to enrich it very high to 90%, 95%. So you have to do the spinning a couple of thousand times and always take that one in the middle. And then you can release within a thousandth of a second with big explosions, these supermassive explosions. So if you want to make for electricity radioactive uranium, then you have it 235% enriched. And when you have a 5% enriched uranium, so uranium with 235, and the rest is just uranium, whatever. And then you can let this uranium 235 very slowly release the energy over months or days or hours, and you get electricity. You get the energy over hours. If you want to build an atom bomb, you're doing this spinning thousands of times, and then you take always the thing of the middle, and then you have 90%, 99% or whatever of uranium 235, and this can be then, however, then made explode, and all the energy in that, all of this thousands of times spinning of it, all the energy in the uranium 235 is released in 1 split second, and that makes this supermassive explosion. Something like that is enriching uranium. I don't know if that means split the atom, But that was what I heard in the meantime since we had that. And I just had to write up a type of it. So I thank you very much, and until next time.